Hello everyone. So I welcome you to the lecture series on MCQ based question answer analysis for the subject artificial intelligence. Today also I am going to discuss four important topics of artificial intelligence and with a question that is involving all these four topics. And this question is very important and the subject matters that I am going to discuss, they are also very important. One question probably being asked in the coming UGC NTA net examinations. So guys, let's start today's class. So today's question is that you need to match this list 1 with list 2. And list 1 consisting of this first one is semantic network, frame, declarative knowledge, and primitive. Then option A given that knowledge about what to do as option A is no means A of list 2 given that knowledge about what to do as opposed to how to do it. Option B, a premise of a rule that is not concluded by any rule. Then option C, a method of knowledge representation that uses a graph. Then option D, a data structure representing stereotypical knowledge. So before answering this question, as I have said, you should have proper knowledge on the semantic network frame, declarative knowledge, and primitive. Then only you could answer this question. So let's discuss each of them. So first, I'm coming to the semantic network. Okay, the semantic network is a graphic notation for representing knowledge in patterns of interconnected nodes. Okay, so semantic networks are also referred as associative nets. As you know, the nodes here are associated with other nodes. Okay, so semantic network consists of nodes, then you have link, and then what link levels. Then in this network diagrams, these nodes appear in the form of circles or ellipses or even rectangular, which represents objects such as physical objects or concepts or situations. Don't worry, when you see the example, these things will be clear to you. Links will appear as arrows to express the relationship between objects, and link level specifying the relations. Then relationship provide the basic needed structure for organizing the knowledge. So therefore, objects and relations involved are not also needed to be concrete. So this is about semantic network, right? So now, main important thing is that you have to know actually what are the main components of semantic networks, and that may be asked in examination. So let's discuss each of them. So first component of semantic network is lexical component. Nodes denoting physical objects or links are relationship between objects, and labels denote what the specific objects and relationship. So you got it. What does it node mean to you in semantic network? So nodes denotes physical objects and links are relationship between them. And the labels denote the specific objects and relationship. These are the lexical component. Okay, you know the term lexical. So these are the lexical component. Then structural components, the links or nodes from a diagram which is directed. This is the structural, means they are forming a diagram, right? Then semantic component means the meaning, that is the definitions are related only to the links and level of nodes, and facts depend on the approval areas. So in semantic component, you are dealing with these definitions and labels, which are actually meaning something with respect to your approved area. Then procedure part is the constructors permit the creation of new links and nodes, and removal of links and nodes are permitted by the structure. So no new links and nodes will be created with the help of constructor, and the structure will remove them. These are the components of what? Semantic network. Now let's take an example. You see this structure. These are what? Our nodes, right? You see this is cat. How you will try to read this diagram or try to understand this diagram. See cat, right? Cat is a node. So cat, this link, you know, this is arrow structure. So this is a link, and what it is representing about the relationship between this node and this node. So cat and mammal, this relationship, the relationship between them is a. So that is cat is a mammal. Again, mammal has, this is a relationship, and this is another node. So mammal node and fur node has the relationship has. So mammal has fur. Ultimately, mammal is a animal, and again about the cat, this is related to mat and cream. So cat sit on mat and cat like cream. So cat like cream. Then again about another node, that is C, always try to actually focus on the direction. You see, cat focuses towards this node, towards this direction with this arrow. So cat set on mat. We will not going to read it as mat set on cat, because the arrow is in this direction, not in this direction. Okay. If it is in this direction, then we will read that mat set on cat. But now cat set on mat. Now similarly, Tom. Tom is a what? Cat. Tom caught Bart. Tom is owned by John. Tom is colored ginger, right? Similarly, Bart is an animal. So mammal is again an animal. So that's it. That is the semantic network. It is also not known as associated network, because you see these nodes are associated to each other through this link, representing some kind of relationship. I hope now this concept is clear to you. Now, if we focus on the advantage and disadvantage of semantic network, then semantic networks are a natural representation of knowledge and convey meaning in a transparent manner. Of course, from the diagram, you have seen that it's very transparent. But the disadvantage is that this may take more computational time at runtime, as we need to traverse a complete network T to answer some questions. And it might be possible in the worst case that after traversing the whole tree, entire tree, you find that the solution actually does not exist in that data. So these are two important advantages and disadvantages. Now, coming to the next part, that is our frames. Now, frames can be considered or defined as data structure. Remember, frames are some artificial intelligence data structure used to divide knowledge into substructures by representing stereotyped situations. Okay, so frames are data structures. Just simply remember this. Okay, and they were proposed by Marvin Minsky in his 1974 article, A Framework for Representing Knowledge. I hope this is clear to you. Okay, coming to the next part. Now, what does frame consist of? Frame consists of what? Slots and slot values. The slots may be of any type and sizes, and slots will have some names and values, and these names and values are called facets. Remember these terms, okay? These terms might be asked in some MCQs. So these slots have some names and values, and they are called facets. So facets, they are various effects, or I can say aspects of a slot, and these are the features of frames which enable us to put some constraint on the frame. I'm repeating it again. What is facet? So facet, you know that slots have some names and value, and they are actually our facets. And these are the features of frames that enable us to put some constraints on the frame. So if needed, these facets, okay, are called when some data of any particular slot is needed. So if needed fact, you can consider this as a constraint. Okay, if needed fact will be called when data of any particular slot is needed. Now, a frame may consist of any number of slots, and a slot may include any number of facets, and facets may have any number of values. So you can now understand that frame will consist of any number of slots, and that slot itself containing any number of facets. So facets are included in slots, and that facets also may have any number of values. So these terms are now clear to you. Now, this frame, as it is containing what? Slot and facets. So this is also known as slot filter knowledge representation. So one question to you, you may answer through comment that what is known as slot filter knowledge representation in AI. You can answer it through comments. So frames are derived from semantic networks actually, and later evolved into our modern day classes and objects. Now, nowadays, you know about these objects and classes. Actually, they are being derived from frames. But you know, a single frame may not be useful, so we need a whole frame system, and that may contain a collection of frames. Now, let's take an example of frame. Now, for that, let's consider, say, Rahul, that is an entity. And Rahul, about Rahul, information is that he is an assistant professor as a profession, and his age is, say, 33. He lives in the city of Jorhat, and the country is India. So the frame for this information or knowledge will be this one. You see, slot and filter. Name, Rahul. Profession, assistant professor. Age, 30T. Martial status, then, marital status, single, then country India, city Jorhat. So this is a frame, and you have seen that we have slots here. So that's why we call this frame as slot filter knowledge representation. Now, if we talk about the advantage and disadvantage of frame, then we can say that as an advantage, the frame knowledge representation makes the programming easier by grouping the related data only. And if you talk about the disadvantage, then inference mechanism. You know, in the last lecture, I have discussed about inference. So inference means deriving some new fact from the old facts. So this inference mechanism is not easily processed in case of frame. So that is the disadvantage. Now, next thing is about, the question is talking about declarative knowledge, but I thought that just knowing declarative knowledge is not is not going to be enough. So I'm considering procedural knowledge as well, and I'm discussing both of them by comparing each other. Okay, so these are the differences between them. So procedural knowledge is about how to do something. Okay, how to do something means how the task is done. That is the procedural knowledge. As for example, to determine if, say, Peter or Robert, who one is older. First, you need to do what? You need to find their ages and focuses on tasks that must be performed to reach to a particular objective or goal. You see, to know that who among between Peter or Robert is older, you have to first find their ages. So it focuses on the tasks that must be performed to reach that goal or objective. Now you can consider the examples of procedural knowledge as procedures, rules, strategies, agendas, models like this. So this is procedural knowledge. Now declarative knowledge is about that something is true or false. We just focus on trying to know that what is true or what is false. As for example, a car has 4 tires. Is this true or false? And then Peter is older than Robert. True or false? See, the difference is that procedure knowledge tries to know how to do something. But declarative knowledge is not actually trying to focus on that how to do something. No, it's not trying to focus. He just tries to focus what is true or false. That's it only. Like Peter is older than Robert. The answer may be either true or false. So it refers to representation of objects and events and knowledge about facts and relationship. So you can consider the example of declarative knowledge as concepts, objects, facts, proposition, assertion, semantic knowledge, logic, and descriptive model. So semantic knowledge itself is an example of declarative knowledge. Okay. So I hope the concept of procedural knowledge and declarative knowledge is now clear to you. Let's move to the next point, that is about primitive knowledge, right? So primitive knowledge is what? Primitive knowledge is a knowledge that is defined explicitly by facts. So we are focusing on the facts. And you can consider this primitive is a premise of a rule that is not concluded by any rule, because it is a fact. Okay. Then derived knowledge is what? A knowledge that can be inferred from other knowledge. And derived knowledge is usually specified in terms of rule. See, primitive is the main one. You can consider this as a fact. Okay, you can consider this as a premise of a rule that is not concluded by any rule. But on the contrary to this, derived knowledge is derived from others. But primitive knowledge itself is some fact. Got it? So I hope this concept on this primitive knowledge is also clear to you, derived knowledge as well. Okay. Now, as you got all the terms involved in the question, so I hope now you are in a position to answer this question. Right. So the questions is this one. You can take a screenshot of this. Now, if you compare this, if you go through the terms very carefully, as I have discussed, then you will get the solution as option D. Right? And what is option D? See, let me come back to the question again. Now, option D is that semantic network is what? A graph, right? You just got it. So semantic network is a method of knowledge representation that uses a graph. Okay. Then what is frame? You know frame is what? You just recall it, what I have explained. This is a kind of data structure. From this given option, you'll find that D is matching. So 2D, that is a frame is a data structure representing stereotypical knowledge, right? Then declarative knowledge. So declarative knowledge and procedural knowledge. See, in case of procedural, we try to know how to do that. But declarative knowledge is just focusing on either true or false. Means what to do, what to choose, right? So 3 is matching with what? A. That is, declarative knowledge is a knowledge about what to do as opposed to how to do it. Right. Then the last one, 4, primitive. Primitive, you know, that is the main one. That is the fact, or you can consider a premise of a rule that cannot be concluded by any rule. Right. So option 4 is matched with B. That is primitive, a premise of a rule that is not concluded by any rule. So that's it. So that's why the option D is clear. Okay, option D is the right answer. Right. So that's it. I hope the question is now clear to you and the solution is as well. Right. So that's enough for today. And if you have any doubt, of course, my comment section is for you to ask me. So guys, with this, Dr. Dibbo is turning out and means signing out. Now we'll meet in the next lecture very soon. Till then, take care. Bye-bye.